Hey, I'm Seth Russell, and this is my informative speech. Think about all the people in your life that you know. Now think about how many of these people are people that you know that work in some sort of area related to the manufacturing sector. Now think of all the small and large factories that you see almost everywhere you go. All these places manufacture different products and materials that we all use in our daily lives. Now imagine your lives without all these manufactured goods because we didn't have the capabilities to mass produce these goods. According to the National Association of Manufacturers, manufacturing supports around 17.4 million jobs in the U.S. This is about 1 in every 6 of the private sector jobs. All these people offer important skills to factories all over the U.S., and they work hard for their paychecks. The United States Census Bureau defines manufacturing as engaging in the mechanical, physical, or chemical transformation of materials, substances, or components into new products. Manufacturing in the U.S. has been a very large part of my life. 40 years ago, my grandpa started an industrial construction company. And when he died 20 years ago, my dad became in charge of the family business. Since I could walk, I was doing things like sweeping the shop floors and sorting supplies. Then, on the age of 16, I started going out to the factories that we work at for start working on the sites. Since then, I have worked in a lot of different factories that do all kinds of different processes, from grinding up recycled pop bottles to casting parts for cars and trucks. Almost everything we touch and use in our daily lives has been through some sort of manufacturing process. Today I'll be discussing shaping operations, surfacing process operations, and assembly operations. All these are very important parts of the U.S. manufacturing. The first thing that I will be discussing is shaping operations. Shaping operations are the operations that actually alter the geometry of the beginning material. Some of the common methods for achieving these are machining, casting, and forging. Casting is a process of melting down a raw material or an alloy, then pouring it into and injecting it into a mold to form an object of the desired shape. This is a very common process for a lot of metal objects and also a lot of plastic objects. One of the factories that I work at is most back home is one of the largest casting plants in Northwest Ohio. They cast a lot of different aluminum parts for Honda and Toyota cars. For plastic items, almost every one of them is cast in a plastic process like injection molding, thermoforming, or rotomolding. Forging is a very common process with metal items. It is done by heating up a starting work, then using a very strong repetitive force to actually shape the desired item. This process is used to make items like swords and horseshoes. Machining is the most common process for actually removing material from the workpiece. The three main types of the machining process are turning, drilling, and milling. Turning is the process where the part is turned and the tooling is held in a single place while it is removed from the material from the workpiece. The piece of equipment that is actually used for this is called a lathe. Drilling is where a drill bit of the desired size is turned at a high speed and then fed into the workpiece to make a perfectly round hole in the workpiece. Some common pieces of equipment that do this process are CNC machines and drill presses. Milling is a process where a cutter is turned at high speeds and then fed over the top of the work. Pieces of the workpiece is fed into it, then removed a layer from the piece. The process is done by milling machines. Once the final geometry is done to the workpiece, it probably has to undergo some sort of surface preparation. According to the engineer's edge, there are three ways to break down surface processing. The first surface process is cleaning. After the part goes through any of the shaping operations, it will have some sort of unwanted residue, whether it is dye grease from casting or coolant from one of the machining processes. It needs to be removed before the part has any other operations done to it. The second process is surface treatment. This consists of processes like sandblasting, shot peening, diffusion, and ion implementation. These processes change the texture and roughness of the workpiece, and they also prep the piece for the third surface preparation process. The third process is coating. The most common one that people think of for this is painting, but these are many processes for applying a coating to a part than just painting. Processes like electroplating, anodizing, and vapor deposition. Once the shaping and surface processes are completed to the parts, they often have one last process to go through, and that's assembly. By definition, assembly is the process of putting manufactured parts together to make a completed product. The first category of assembly techniques are the permanent ways, things like welding, gluing, brazing, and soldering. These processes take two or more parts and create a permanent joint between them by adding a filler material. The second category is mechanical methods. These methods can usually be disassembled if wanted, fairly easily if wanted. It consists of things like bolts, screws, nuts, and tabs. Manufacturing is a very vital part for all the luxuries we use in today's world. Throughout my life, I have had first-hand experience with all the different manufacturing processes, including shaping, surfacing, and assembly. Almost everything that we use and touch in our daily lives has went through these manufacturing processes. If you ever have the choice to tour a factory, make sure you do. You may have the thought that they are boring, dull places, but they're actually very interesting places full of technology.